2017. Please, before we start, if you do have a device that makes a noise, please convince it not to make a noise, or else I'm going to come over and stare at you personally. Our next speaker is Deborah Hanus, and she's going to be teaching us about predicting Oscar winners. Please make her feel welcome.
Hello, everyone. Today I'm going to talk to you about how to predict box office hits and Oscar winners using things you found on the internet. To start off with, I'll tell you about how I got to doing what I'm doing today. I did my undergraduate and my master's at MIT, where I studied computer science and did all of my undergraduate research developing computational models of how people see and perceive things. Then I spent a year as a Fulbright scholar in Cambodia learning about how education translates into job creation. Then I worked as a software engineer at a startup in San Francisco. And then I decided to quit life and become a PhD student. So now I'm a PhD student at Harvard studying machine learning. And as part of that, I get to work on a lot of exciting data-related projects like this one. So to start off with, we'll talk about how to build and use a great data set. And the first and probably most important step is to define a question that you can actually answer. Then you want to acquire good data to answer that question, explore the data, and draw conclusions from that data. And today we'll step through all of those processes. So we'll start by defining a question we can answer. And today we are all going to pretend that we are movie producers. We have money and we're going to pay for movies to be made, but we want to get something in return. Preferably a huge stack of cash. So how can we answer this question? What we really want to know is, will this movie be a box office hit? But it's pretty hard to answer that question. How do you define that? So a better way that we might phrase this is, what is the likelihood that my movie will be a box office hit, given that it has certain features? And another way that we could ask this question is, what attributes of a movie are correlated with box office success? So that is the question that we're going to be answering today. So now we want to acquire good data. So first, let's start off with, what is good data? We want it to be relevant to the problem at hand. We probably want it to be relatively structured. If it's stored in some sort of table or something like that, that makes it a lot easier for us to acquire. Ideally, we want it to be relatively complete. If it's not relatively complete, there's a whole field of research and another talk in how to deal with that. So some of the places that we found data for this project are one, Box Office Mojo, which is this great 90s style site with this excellent table, which gives you a lot of information about the top movies, the top grossing movies in each year. Another great place is Rotten Tomatoes. Also has a lot of really structured data. For every movie you have things like a rating. Wikipedia is perfect for things like this. It has that great box in the corner which has the title of the movie, producer, director, meaning that it's formatted in the same way, making it much easier to grab. And so also IMDb is another great place to get this sort of data. Okay, so now how can we get this data? One way is we can use an API, which is just a group of functions that are defined like get movies, which will go and get all the information for movies. And that is usually defined by the person producing the data. So in our case, we used IMDbPy. And the other is to write a web scraper. And to write a web scraper, we need to start by getting all of the text that is in the web page, bringing it down to our computer, making it queryable, and then we can do stuff with it. So to start off with, we're going to make an HTTP request to get the HTML. This is what Box Office Mojo looks like. Isn't it beautiful how structured it is? So there are a couple interesting things to point out here. The most interesting right now is the URL, because the URL actually tells us exactly what information we're going to get from this. So we're going to zoom in and look a little bit more closely at this. After the question mark, there are a number of parameters which define what information we're going to get. Most relevantly, there is a page number. The page equals 1, and then we're looking at the items for 2017. We can see from the last parameter. So we can get information from all of these pages. So this is just a snippet from a Jupyter Notebook, and we're using the requests to make a GET call using that URL, and we're looping through all of the pages. Notably, we're pausing between each grab, and we'll talk more about that later. And then we're putting all the items in a dictionary, and if we look at the first item in the dictionary, it is just raw HTML. Very, very unreadable raw HTML. So to make this more usable, rather than using a bunch of regular expressions, we can make it queryable using something like Beautiful Soup or PyQuery. So what those do is they translate something like what's on the left, the HTML, into a sort of parsable tree that you can just go through, like get all the child nodes or things like this. So if we go back to the site, we have that table, and we can go right-click, view source. We get that completely unreadable wad of text. However, if you look, there are some patterns, particularly if you were to Control F and find the title of some of the movies. You would see that everything in the table has font size equal to 2. So you can go and grab everything with font size equal to 2. And now we have this list of all of those items. If we select one of them, we can see that that is the top grossing movie, Beauty and the Beast. But it still isn't quite in the format that we want. So the Beauty and the Beast title is in this link tag. So we go and find the link. And then we get text, and then we have the title in the form that we wanted it in. So this looks pretty easy, right? Hopefully I made it look relatively easy, but it's actually often is not that easy. So we're going to go over some common problems that people run into. One is rate limiting. So if you go and you try to scrape a web page, often the host will try to identify whether you are a person who is clicking and requesting information, or whether you are a machine which is requesting information as quickly as you can. So it's a good idea whenever you're writing a web scraper to use a time sleep method to put a bit of a delay in there, so that, which is approximately the delay at least of a human clicking through. So like usually 1 second is enough of a delay. You can also limit access to your data based on who you think a person is. I gave this talk once before, and someone afterwards told me a fantastic story. They were working at an open data company. And they had and so most of the data was open, but there were some things that they kept to themselves. And they had a competitor who was not very sportsmanlike and scraping their web page to get all of their open data. So they wanted to prevent this, and the way they did this is they put the first way is they put an API key up, so that they could tell who was accessing the information. However, then their competitors spoofed the Google web crawler API key, so it looked like Google was crawling through their site. So the way they ultimately got around this is they made a one-page, like an AngularJS app, so that that was less easy. And then the way to get through that is to use browser tester like Selenium, which can click through each of the items for you, and then you can access the data that way. Okay, so we've talked about how to get the data. And now we're going to start exploring some of this data. So there are a number of factors that we can explore given the data set that we have. You could imagine that movie budget might be important. Maybe a movie that has a really big budget is going to make even more money. IMDb rating might be important. You would suspect that good movies would make more money. Maybe if a movie comes from a power studio like Warner Brothers, maybe it'll make more. The amount that it makes in the opening weekend might also be predictive of how much it'll make in the long term. You might imagine that there's some sort of a saturation of opening theaters that would be good. If you open a movie in too few theaters, there will be people who want to see it who can't. And if you open a movie in too many theaters, you'll have a lot of empty seats and you'll start losing money. Seasonality, there might be some movies that people like to watch at some times rather than others, like Christmas movies. And then the MPAA rating, this is like if it's G, PG, etc. So we're just going to start by exploring the data and making some basic plots. So this is going to be the gross revenue versus the number of opening theaters. Looking at that, it looks like there actually is sort of an inflection point. That is a good number of theaters for you to use right there, around 3,500. So this is interesting. When we do create this movie, we want to probably open it in about 3,500 theaters. So now we'll look at something else. Gross revenue versus quality rating. And so you would expect that if a movie is good, that might be predictive, but it looks like it is not at all. We would normally look, if it went along that line, that would mean that there was a correlation, but it seems there is absolutely no correlation. Good movies do not make more money. However, and so then we can also look at the amount of money that a movie makes in opening weekend versus how much money it makes in general, and it looks like if a movie makes a lot of money in that first opening weekend, then you can expect it to make a lot of money in general. So this looks like it is relatively predictive. So then we combined all of these into a multivariate regression. And we found that the model seemed to fit quite well. Great. So we've explored the data a little bit. I've taken you through some of the things that we looked at. A lot of this analysis for the determining if something was going to be a box office hit was a lot of linear regression. So now we are going to draw some conclusions. We found that budget helps, but it doesn't help very much. We found that timing is really important. It seems like December is a great release date, which sort of makes sense. Like December is often a time when a lot of people go to the theater to watch movies with their family. You're much more likely to go with 10 people in December than you are another time. We found that PG and G-rated movies make more, which I think also makes sense. I think a lot of people find it awkward to watch other such movies in a larger group. And we found that the money made in the opening weekend is very important. Okay, so we've talked about what it takes to make money. So now, what does it take to win an Oscar? So to answer this question, we'll use the same steps that we used before. We want to define a question you can answer, acquire good data, explore the data, and draw conclusions from the data. So that now we're going to say all of us are actors. We are maybe Leonardo DiCaprio, and we want to figure out if we act in this next film, are we going to get an Oscar? So the question that we really want to know the answer to is, will this movie win an Oscar? An easier question to answer might be, what's the likelihood that this movie will win an Oscar, given that it has certain features? Or what attributes of a movie are correlated with the movie winning an Oscar? Okay, so now we need to acquire the data. And this turned out to be a little bit harder than we expected. IMDb, we did this entire project as a class project for a data science class, meaning that we did everything in approximately 2 weeks. And we found an IMDb Pi has this API that lets you make a call to get certain movie information, but they also sell their information via a professional service, so they don't want to give out too much information through this. So they make their API extraordinarily slow, like a good 5 to 10 seconds per movie. So we were able to get some interesting information, but while we originally wanted to look at all of the recent movies between, say in the last 10 or 15 years, we found that that was going to take a month for us to get all of that data. So we had to go back and reevaluate our questions. We couldn't answer any of these. But what we did find is we did find a CSV of all of the movies that had been nominated from 1980 to 1996. So then we were able to do an analysis, reevaluating the data that we had. We were going to said, given that a movie has been nominated for an Oscar, since that's all we don't have all the other movies that existed, what attributes are correlated with winning? And can we make a classifier to predict Oscar winners? Okay, so we started out by exploring some of the data. And here we had a sort of different set of factors that we could explore. We looked at the movie nomination category, so you could be nominated for Best Picture, you could be nominated for Best Cinematography. We also had a lot of really great binary variables based on the thematic content, like, is this a movie about family? Does it have violence in it? Is it about war? Does it contain smoking? I thought that was a great one. And then you could imagine perhaps dramas are more likely to win an Oscar than horror movies, so maybe movie genre affects things. It's possible that where the movie is made might affect things, or when during the year the movie debuted. So we started to explore some of this data. First, we looked at the countries associated with winning Oscars. And we found that if the movie, given that a movie was nominated, if it came from Italy or Spain, it actually had a very good chance of winning, even better than the United States. Then we wanted to look at the effect of timing, like when the movie comes out. So first we looked at the number of winning movies per month. And if we look at this, it looks like December is the clear winner. We definitely want our movie to come out in December. But then we thought more about it, and we realized that there might be different numbers. It's possible everyone is in on The Secret, and there might just be a lot of movies coming out in December. So instead, we normalized this based on the number of movies that came out. And we found that, well, December is not quite as obvious. You definitely want to release your movie in the last half of the year, between July and September. And I haven't gone through all of our analyses here, but next step is drawing conclusions from the data. And we found that nominated films made in Italy and Spain have a good chance at winning, like we just saw. Films are more likely to win if they're released later in the year. Violent movies really don't do well unless it's a war film. Oscars love war films. And then the violence is okay. And if a film is nominated for Best Picture, it has a very good chance of winning. But if it's nominated for Best Cinematography, it's probably not going to win. Okay, so what have we done in this process? We defined 2 answerable questions. We built a web scraper using requests in Beautiful Soup. We explored our data. we used it to answer our questions. And I wanted to acknowledge the rest of my team. I asked them all for photos of themselves, and they all sent me photos of birds. And that was when I knew that it was going to be a great project. And then, for those of you who want to get started scraping on your own, some of the resources that we used were, for building a scraper, are requests and beautiful super PyQuery for making the text queryable. For analyzing the data, we used Jupyter Notebooks, scikit-learn, stats model. And I'd say one of the best ways to learn is by looking at example projects. And what we did is we, in addition to putting together a website that sort of summarizes a lot of our results, we also put all of our Jupyter Notebooks online, where we step through exactly how we got the data, what our thought process was on each of the analyses and building the classifiers. And so I encourage all of you to take a look at that. And if you're looking for a starting point for your next data science project. And obviously, you should feel free to reach out to me anytime. That's my Twitter handle. And thank you very much.
Thank you, Deborah. If anyone has any questions, if they'd like to come up to one of the microphones in the aisles.
Hey, so one of the learnings from the first thing that you explored was that if you have a release in December, then your earnings are really high. And then when you looked at the Oscars, you saw that, again, later half if you release it, you win Oscars. Do you think there's a correlation between earning a lot of money and winning Oscars? And if you do, then does it make sense? Do you think that model would predict better if you were using the earnings instead of when it was released?
That is something that we thought about, and we really wanted to do that analysis, but we ran into issues because, like I said, with the IMDb Pi, we weren't able to get the award information from all of the years that we wanted in order to run that. But I agree that that is potentially a very interesting point to go through, and
so
just from what I saw, I would believe that that is plausible.
But so how do you explore something like that? Like in this case, I'm using common sense to say, oh, you're earning more, therefore you're probably winning the Oscars. But in a more esoteric situation, how would you deal with such correlations? Like what would you recommend as best practices?
Having trouble answering that question on the spot, but I'm happy to talk to you more about it afterwards.
Okay.
Hi. I was curious about how you knew if a movie contained violence or smoking. Was that data from IMDb as well, or is it just sort of?
That was, we got this spreadsheet, a CSV, with all information about all of these movies that had been nominated from the 80s to, I think, 1996. And it actually gave us all of those variables.
Wow, okay.
So they had a bunch of variables which were like, is this about a war, 1, 0? So it was really nice because we were able to look at all those binary variables.
Okay, cool. Thank you.
Are there any more questions?
If there are no more questions, oh.
I have a question.
Yes.
How can you in the end, when you make your prediction, prove how good your prediction is or measure how good your prediction is so that the new movie comes out and you would then say about if it might win an Oscar or not, to how much percent or so? How you do that?
Yeah, that is actually a great question, and I had a deleted section of my talk that went over that, in fact. So usually you would train a classifier on previous data, and then you can measure the accuracy on some test data, so you would need to look at probably some recent years. So perhaps you could use the data from 2016, since that's past, and just remove whether or not it won an Oscar, and then see how accurate your prediction is. Another really important thing to think about when you do that is to look at the baseline. So in this case, when we're looking at how accurate a classifier is, you want to start by saying something like, rather than just saying, we predict 70, we have 70% accuracy and that's great, you want to look at, well, what if we predicted them all to be losers? It turns out that that's actually pretty close to 70% accuracy. You want to look at if everything is a loser, everything is a winner, and then you can use those as baselines and see if your classifier is better than that.
Thank you very much.
Yeah, no problem.
Are there any more questions? Thank you, Deborah.